Part of your notes for section 4.3. Go ahead and scroll all the way to page 5 where you have your blank unit circles, and we're going to talk about putting together what we learned in section 4.2 about combining degrees and radians. Okay, so first let's go around and label everything using degrees, and then we'll go back and talk about radians and how to help you remember how to count around the unit circle. Alright, so we start at 0 degrees. If we were to go halfway, that would be 180. Halfway between 0 and 180 would be 90 degrees. Halfway between 180 and 0, or 360, if we went all the way around, would be 270 degrees. Okay, so if we look at it in halves again, halfway between 0 and 90 would be 45 degrees. Halfway between 90 and 180 would be 135 degrees. Halfway between 180 and 270 would be 225. And halfway between 270 and 360 would be 315 degrees. Okay, and then next, if we do it in increments of 30 degrees, then the first one would be 30, 60, we already have 90, and then 120, 150, we already have 180, 210, 240, and remember we're just counting by adding 30 degrees each time, 300, 330, and then we would end up back at 360. Okay, so now let's go around and talk about that in terms of radians. We're going to do that on the first circle, and then we're going to do that again on the second one. So you can copy over those values if you'd like to, so you don't have to rewrite them. Alright, so 0 degrees is the same as 0 pi. And we said that if we went all the way around the circle, that would be 2 pi. So halfway around at 180, that would be the same as pi. Halfway between 0 and pi would be pi over 2. And then halfway between pi and 2 pi would be 3 pi over 2. So then halfway between 0 pi and pi over 2 would be pi over 4. So now you can think of it as counting in pi over 4s if you remember that pi over 4 goes with 45 degrees. So we can put a understood 1 here. If that's 1 pi over 4, then pi over 2 is the same as 2 pi over 4. But we don't call it that, we just reduce it and call it pi over 2. 135 degrees would be 3 pi over 4. Pi would be the same as 4 pi over 4, but we don't call it that, we just reduce it and call it pi. 225 would be 5 pi over 4. 3 pi over 2 would be the same as 6 pi over 4, which reduces to 3 pi over 2. 315 would be the same as 7 pi over 4. And if we end up back at 2 pi, that would be the same as 0 pi over 4 or 8 pi over 4, which reduces to 2 pi. Okay, so those are all of the degrees around the circle. We count in increments of 45 degrees and then increments of 30 degrees. And then we talk about how that matches up with our radian measures. And so those we count around in pi over 4s, which is the same as 45 degrees. Okay, so on the second circle, we're going to count around by 30 degrees. So for the first one, we already know that this is the same as 0 pi. Or 2 pi. And then halfway around the circle would be equivalent to pi. And then if we break up the unit circle or the first half of the unit circle into sixths, then this would be 1/6 pi. This would be 2/6 pi, which we don't call that. We reduce it to pi over 3. "90 degrees would be the same as 3 pi over 6, but we don't call it that. Instead, we reduce it to pi over 2. 120 would be the same as 4 pi over 6, but we reduce that to 2 pi over 3. 150 would be the same as 5 pi over 6, and then pi would be the same as 6 pi over 6. Okay, and so we're going to keep going. The next one would be 7 pi over 6. 240 would be 8 pi over 6, which reduces to 4/3. The next one would be 9 pi over 6, which reduces to 3 pi over 2. At 300, we have 10 pi over 6, which is the same as 5 pi over 3. At 330, we have 11 pi over 6. And then back at 2 pi, that would be the same as 12 pi over 6, but we reduce that to 2 pi. Okay, so we've gone all the way around the unit circle. On the first one that we did, we counted in 45-degree increments or pi over 4 increments. And on this second unit circle, we counted in 30-degree increments or pi over 6 increments. So if it helps you the first few times that you go over this, count all the way around in pi over 6s and then just reduce your numbers. All right, so the next thing is going to be to take the unit circle and tie it into x and y coordinates that we're going to get from our special right triangles. So let's do the multiples of 45 or pi over 4 first. That means that we would start at 0 pi, which is the same as 2 pi. And in degrees, that would be 0 degrees or 360 degrees. And then we'll go around and count in degrees, and then we'll come back around and count in radians. So this would be 45 degrees. Add 45 and you would get 90. Add another 45 and you would get 135. Add another 45 and you get 180. Add another 45 and you get 225. Add another 45 and you get 270. Add another 45 and you get 315. Add another 45 and you end up back at 360. Okay, so now if we go around and we talk about radians, that would be the same as 0 pi. 45 degrees is the same as pi over 4. 90 degrees is pi over 2. Remember that that's the same as 2 pi over 4, but we reduced it. At 135, we have 3 pi over 4. At 180, we have pi, which is the same as 4 pi over 4, but we reduced that. At 225, we have 5 pi over 4. At 270, it's the same as 6 pi over 4, but that reduces to 3 pi over 2. At 315, we have 7 pi over 4, and all the way around would be 2 pi, which is the same as 8 pi over 4. Okay, so that's exactly the same information that we went over in the previous one, but now we only have the multiples of 45, and now we're going to find x and y coordinates for those points on our unit circle. So this is based on a unit circle having a radius of 1. That's really important to remember. Okay, and then because the radius is equal to 1, we're able to apply a right triangle and use Pythagorean theorem. Okay, that right triangle is the same one that we can draw into our unit circle. And it would go right there. Okay, so this radius is equal to 1. If the radius is equal to 1, and we know that that's a 45-degree angle, then this also has to be a 45-degree angle, which means that those two sides are congruent to each other. So if we use our special right triangle rules, then this would be the radius, or the hypotenuse, and each of those would be the legs. Okay, so on a special right triangle, the leg is equal to x, and the hypotenuse is equal to x times square root of 2. Okay, so if our hypotenuse is equal to 1, how do we go backwards and find the length of the leg? So if it's equal to 1, then 1 is equivalent to 1 divided by square root of 2. And if we simplify or rationalize that, that's the same as root 2 over 2. Okay, so that was an application of our 45-45-90 rule. Which hopefully you remember from geometry. And now we're going to put that into our unit circle. So that means that this length is root 2 over 2 and this length is root 2 over 2 if the radius is 1. That means the coordinates at 45 degrees would be square root of 2 over 2, square root of 2 over 2 for the x and the y values. Sorry, I'm trying to make this a little bit smaller here. Okay, so if that's square root of 2 over 2, then we can take that same right triangle and we can reflect it into the other quadrants. So if we do that, that means we go negative root 2 over 2 and positive root 2 over 2. And again, the radius is 1, or the hypotenuse on our triangle is 1, which makes the coordinates at 135 equal to negative root 2 over 2, positive root 2 over 2. Okay, and then we're going to reflect that triangle once again, basically into each of our quadrants. And in quadrant 3, those coordinates would be negative root 2 over 2, negative root 2 over 2. And then the last one that we would reflect it into would be into quadrant 4. There's our right angle. And the x and y coordinates on this one would be positive for x and negative for y. Okay, so what we've done is we've taken the special right triangle rules for 45, 45, 90 degrees. We started with a hypotenuse that was equal to 1 and worked backwards to find the length of the legs. So the legs would be equal to root 2 over 2. And then we put those x and y coordinates into our unit circle. We applied it first in quadrant 1, and then we reflected those same things into quadrant 2, 3, and 4. Okay, so that was for 45, 45, 90. Now we need to do the same thing for 30, 60, 90. Okay, so on this unit circle, we're going to go around and count everything again. It's good practice. We're going to do the degrees first, and then we're going to do radians, and then we'll put in our special right triangle. So we would start out at 0 degrees, and then we're going to count around by 30s. So 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, oops, sorry, 300, 330, and then back at 360. Okay, now we can count around using radians. This would be the same as 0 pi. Pi over 6. 2 pi over 6, which reduces to pi over 3. 3 pi over 6. which reduces to pi over 2. Four pi over 6, which reduces to 2 pi over 3. 5 pi over 6, which we don't need to reduce. 6 pi over 6, which reduces to just pi. 7 pi over 6, 8 pi over 6, which reduces to 4 pi over 3. 9 pi over 6, which reduces to 3 pi over 2. 10 pi over 6, which reduces to 5 pi over 3. 11 pi over 6, and then all the way back at 12 pi over 6, which reduces to 2 pi. Okay, so we have counted all the way around by 30 degrees or by multiples of pi over 6's. Now the next thing we need to do is go in and put our special right triangle, but this time we're going to use our 30, 60, 90. All right, so there's our 30, 60, 90 triangle, and we're going to draw the same one out to the side and label everything. Remember that a unit circle has a radius that's equal to 1, and that's how we're able to label all the x and y coordinates. So once again, unit circle, and the radius always has to equal 1. So if this is 30 degrees and this is 60 degrees, this would be my short leg, my long leg, and the hypotenuse. So the rule is, whatever the short leg is, the hypotenuse is twice that much, and the long leg is the short leg times the square root of 3. So if the radius is equal to 1, then to go backwards and find the short leg, that would be 1/2. And then the long leg would be whatever the short leg is times square root of 3, or 1/2 times square root of 3. And instead of writing it as two separate fractions, we just write it together as 1. Okay, so in our right triangle, our longer leg is square root of 3 over 2. There's our 60. Across from the 30 is our shorter leg, which is 1/2, which means using our x and y coordinates, our x value is root 3 over 2, and our y value is 1/2. Okay, now we can take that measure and we can reflect it into the other quadrants. Okay, so there's our 30, 60, 90. Our coordinates would be negative for x and positive for y. So negative square root of 3 over 2, and then 1/2. When we reflect it into quadrant 3, not quite the right length there, but that's at the right place. So both the x and the y coordinates should be negative. So this would be negative root 3 over 2, negative 1/2, and then reflect it into quadrant 4. And those coordinates would be positive, negative. So square root of 3 over 2, negative 1/2. All right, so far all we've done are the increments of 30. Now we need to go back and do all the increments of 60s. So that would be a different triangle. Okay, and that triangle, if we draw it out to the side, it's just flipped. So there's my 60, there's my 30. This would be my long leg, my short leg, and my hypotenuse. My hypotenuse is the same as the radius, so it's equal to 1, which means the short leg is 1/2, and the long leg is square root of 3 over 2. So on the purple triangle, this length is equal to 1/2, and this one is equal to root 3 over 2. So for the x and y coordinates at 60 degrees, they are just flipped. Instead of root 3 over 2 1/2, we have 1/2 root 3 over 2. Okay, now we need to reflect that into the other quadrants. In quadrant 2, we would have a negative x value and a positive y. In quadrant 3, both would be negative. And the last one, in quadrant 4, we have a positive x and a negative y. All right, so I know that looks very busy, but we won't have to put all of that information onto our final unit circle. The purpose of this was to show you where all the measurements came from. So if you can understand how we applied the degrees and radians together, and then put the two special right triangle measurements into there, then you'll understand where the unit circle came from. Alright, so on the next video we're going to start by completing a unit circle, but we're not going to put the not reduced measures on there, and we don't have to draw the little bow tie triangles in there either. We're just going to write the x and y coordinates.